Hi, fellow learners. So today I've decided I can tackle something. So directly, this question, was in some series. I can't remember well, but here is area by coordinates. I need to show you something. So how this area by coordinates equation is gotten. So this is just a simple. We can treat it like a simple class tutorial. So area by coordinates. So this is Gatgara Steven, lecturer, Sibet Sidak. So currently at my technical. So let's prove this formula. So proving the formula. So in a particular case of traverse survey, which are plotted from coordinates, it is more convenient the area from the coordinates themselves. So considering the closed traverse A, B, C, D, then we remain. So we go back to A, whose stations have coordinates. This is the easting for A, easting for B, nothing for A, nothing for B, etc. We can relate the two axes whose origin is 0, and those two axes that we are speaking currently, so this is the north and the east. So whatever case, how this diagram looks like, the area by coordinates can be gotten from there. So from the area of trapezium, so the areas can be found. So this question is gotten, so we divide the areas into smaller areas, and by dividing them into smaller areas, we will see how to calculate there. So the area, the total area A, B, C, D, E, A. So this full area found here within our boundaries there. So that area can be located by dividing that into the smaller section. So it can be located by, so here we have area A, B, P, T. So these are random, we choose so random initials. So AB, PT. So these are trapezium. As you can see, these are trapezium. So is equals to this trapezium plus this trapezium B, C, Q, P. So this trapezium here. Then plus the last trapezium C, D, R, Q. Then so these are total of the trapezium, and as you can see, the trapeziums are going up to the bottom of the diagram, but our diagram is only found on the topper section, so we have to minus the others. So after adding the 3, so this is 1, 2, 3, the 3 trapeziums, you subtract the trapeziums found below. So we can start here. So this we subtract D, E, S, R. So this trapezium 4 found here below the diagram, then minus trapezium E, A, T, S. So this is another trapezium 5. So in these questions, the larger trapezium, there, as you can see, we've used the different color. So by having the larger trapezium, we subtract that to the smaller trapeziums found here below our markings. So these the trapeziums that I'm looking for. So by doing that, so let me rub this a little bit in order for that to be clean. So we subtract those trapeziums there. After subtracting that, we'll have gotten our area. So you remember that. So let's go directly from the areas of a trapezium. Let's go to the first trapezium, ABPT. So ABPT, let me use this diagram here. AB, so this ABPT, so these are trapezium, and the formula of finding a trapezium is a half into A plus B multiplied by H, that is the height. In this case, we can say here is A and here is B, then the distance between here, that is the H. So this is the trapezium that I am in search for the area. By having this formula, so this will be a half into, so A is represented, so the distance A is from here 0 to A, and that means that is the nothing. So the nothing, they all originate there from the 0, so the nothing goes by dimension, so they increase upwards. So the distance between 0 here, found here, to A, that is the nothing of A, that is the distance that will be at A, so that is nothing of A. And then B here, the distance from here, it is 0 on the axis where the nothing is represented. So from here to here, that is the nothing of B. And then the distance between here and here, so that distance between that is P and T and P, so from here to here is the easting of A. So this is the easting of A, the distance between 0 to where A is on that axis. Then the distance between here 0 to B, that is the easting at B. So if we had figures, you could have identified, so the easting of A was lesser and that of B was greater than that of A, because they all originate from this 0. So that is simple traverse, or we can just say computation, so survey computations there. So the distance between here to here is the easting of A, and from here to here, that is the easting of B. In order for us to find the difference between those two, that means our H here will be easting of B, that is the one that is greater, minus the easting of A, that is the one that is lesser. So these two will represent my H in the calculation. So that becomes, so a half into A plus B, and then multiplied by H, this is the H, so easting A minus easting in B. So remember that. So that is from the trapezium, so that is the formula of the trapeziums. So by doing that, then we move to the second. So here our second, that is BCQ. So BCQP will do the same. So here will be presented by A, and that is B. So here that will be a half into A plus B multiplied by H. So here the distance from here to here, that is the nothing of B, plus the nothing of C, the distance from here to here, that is the nothing of C, then multiplied by our H, and our H is the distance between P and where our Q is. So this is our H, we can say that is the H2. Yeah, this we can represent them there, so that is H2. So this distance from here to here, remember earlier I told you, so from here is the origin, so the easting of B is the distance to there, then the easting of C is the distance to here. So the difference between these two will give me my H2 there. So here we have the easting of C minus the easting of B, giving me H, and that will be simple, just like how we can see. So this is a half nothing A, not plus nothing C multiplied by easting C minus easting B. So these are just the representation that we had here earlier. So these are the representations that I'm written there for you in order for you to remember. So by having that, so let me rub these a little bit so that we can have space for another calculation. So you make sure you remember. So these are the two that I've done. So let me do the others. So let me rub all of it in order for us to have more room on our board here, our online board. Yeah. So let's move on. So and then we have the last addition. So this C D R Q. So you can arrange in whatever form you want. So but mostly I like going clockwise, sometimes unclockwise. So but either way it will be right. So the area, so these are half into, so this A, this B. So A is the distance from here, our 0 to where C is. So that is the northing of C. So that is the northing of C plus the northing of D. That is the distance from 0 here to where D is found. Then multiplied by H. H is the distance found here in between there. So that can be H3. So the distance between Q and R. Then from here to where our Q is, that is the easting of C. That is the distance where our easting of C. Then from here to D, that is the easting of D. So we subtract these two and it will give us our H. So that will be multiplied by the easting of D minus the easting of C, are represented here well. So this is just the simplest way possible. Then our subtraction. So let me rub these. So we go to our second last area. So our second last area here. So there is DESR. So DESR. So this is the figure that we are subtracting from that of the bigger figure there. So here we can say, yeah, this can be A, this can be B, and then H is the distance between S to R there. So that can be H4. So this will be a half into A. A is the distance from here to where E is, and that is the northing of E, plus the northing of D, that the distance from here to where D is found, the northing of D. Then multiplied by H, that is the distance between here and here, so that the distance between S and R. So from here our origin of 0, here will be having the easting of E. Then from here to here, that will be the easting of D. So the easting of point D. So because this is the traverse, that is the easting of that point there. So that will be the easting of D, because that is the highest, minus the easting of E. So that will be H. Well represented here. So that is the equation. And as you can remember, I've told you, so these are the subtraction. So we're subtracting this, and we're also subtracting the last part here. So area EATS, it's, so this is the last area that we are subtracting from this diagram here. So let me rub this again. So I want to have a cleaner work in order for your understanding to be a little bit easier. So I'm sure by the time I'll be finishing this, you'll have a good concept. So this is the last area here. So E A T S, this is the last area that we are looking for. So that is half into, we can say here it's A, here it's B, then the distance from T to S, that will be our last H, so H5 or A5, B5. But if you can, yeah, you can avoid that, it is not necessary. So here A, that is the distance from here, this is the origin 0 to where our A is found there. So this is the nothing of A plus the nothing of points E, so the nothing E multiplied by H is the distance T to S, so that will be this is the easting of A, this is the distance from here 0 to where A is found, so the easting of A, and then here the distance from here to the easting of E, that is that. So we subtract those two, so that is the easting of E minus the easting of A, and that will give us the final equation. So we subtract that. So this just I've separated the areas in order for you to understand where the easting and the nothing came from, and I hope you have understand. If not, you can repeat again so you can rewind the video. So let me go to solving the final the near final equations. So the total areas, I have taken everything that is here, so I have taken everything that is here, and those areas that we were supposed to add and those that we were supposed to subtract, I've done that. So this is what I've done, so I have done that. So my area A, B, C, D, E, return. So this is the area that I am now looking for after having solved the bigger portion minus the smaller portion here, in order for me to find the area that I'm shading here, and that is the area of that diagram that we are having there. So I think this is just a little bit so I hope you are understanding something down here. So let's go directly to solving simplifying, so we can say that simplification. So we have a half, this is a common, so it's common in all our equations here, so it is common, so a half is found everywhere, so this is the most common. So in order for me to make sure my simplification is just right, so I have put everything in bracket. So this is a half into, so here we have my general bracket. I've taken everything that we have done here and inputted that on our so everything here I've taken it directly and inputted it on my simplification. So I'm going to simplify what we have done earlier, so you remember that. So after having, so these are my all the data that we have calculated. I've included the signs, so you remember the brackets, so we have the brackets there. So here we multiply, this is just like math, so we multiply this nothing of A multiplied by the easting of B, and also the nothing of A multiplied by the easting of A. Then we'll do again for that of the nothing of B multiplied by easting B and easting A. And here in this very somehow it seems tiresome, but it's easy. So here make sure you remember where the signs are. Those are the most important. In opening your brackets, remember where we have our signs. Something like the general negatives will affect everything that follows them. So these two negatives, remember, they will affect everything that follows them because of the big brackets. So by simplification, here we have the nothing of A, nothing of B. So this is just something that you can do. I'm not seeing it. So you remember, you multiply. So the so this is just like so this that concept of mathematics where we multiply our values here. So you make sure you open the bracket, and that means you multiply everything. So also this will be nothing of B multiplied by everything found here, and also the nothing of C multiplied by everything found there. So you'll do the same to every single one of them. So that also you'll do that, and the same and the same. So by doing that, we'll have all our values here. And you remember the negative signs, so you make sure you follow the negative signs to the latter, because they change everything. If you input a negative where it was supposed not to be there, you will change everything, and your final simplification will have an error. So you remember that, you make sure you do that well. So make sure you do that. So by having all that there, we look at similar, the values that were similar. So here this value, we didn't have any similar value to it, but here we have the nothing. A is somewhere on our equation, so you go ahead, you look for it, and then we have here on our final the same. So there we have no similarity. So I'm saying similarity because here we have a negative and here we have a positive, so they are cancelling each other. So that's the simplification that I'm speaking about. So the same to this, it cancelled, so it's here, it did cancel that. Say the nothing C is thing C also cancelled here, and you see the signs. So the signs, so when you add subtract, that becomes a 0. Then this also did cancel, and our last also cancel. So after simplification, what is remaining is what you're going to do on the next. So we go ahead and we simplify it again. So by having this, so we simplify this. So I'm looking for something with common, so I can decide to use the things as the common things that are found here. So you make sure you find where our things are common. An example of this, so this is nothing of A, thing of A. You go ahead and you survey. So we are looking, and here we have it. So we have a thing of B. So you make sure you those values are brought near to each other. The same, so thing of A, you go ahead and you look. So here we have a value that is similar to it. Then thing C, here we have it. Then thing E, here we have it. And then our last thing D, here we have it. So this is what I've done here on the next simplification. And then on our last, so by having that thing, so I'm simplifying it further. So I'll just open again the brackets. So by having these things, so the nothings will be brought inside the bracket, and this will be my final equation of the diagram that we were looking for. So this can change depending on some of the illustrations. So this was just trapezoidal that was this similar. So you can do another. I'll have another video of a different diagram in order for you to understand more. So make sure you watch the next video of the same, so the area by coordinates. So here we're proving the formulas, how they got our formulas. And I had seen such a similar question. Make sure you go ahead and you look for it. So you remember to see the next video. Thank you.